I'm just starting the recording, and let me sit here. I hope everything will work okay. And yes, so once more, I should put somewhere here to have the to have such a connection. And a few more. I need something to put here, just a moment. Yeah. Okay, so I hope now it will be okay. But let me start today to say a few words about such a conception as Umpolung. 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 This is a concept of Seybach. Somewhere from 70s, and basically if we just draw the situation which we have already analyzed in one of the latest lecture, so such a double function molecule, and maybe you remember that we performed the disconnection here, and that we performed it in the mode which was indicated by this arrow. So this means that we would have a minus sign here and a plus sign here. But what if we change the direction to this B, and if we have such a polarity of the symptoms that we will have a plus here and a minus here. So basically we have changed the polarity, and we would have O1, 2, so acceptor 2, and O1, donor 1. And let's one more divide the page into two separate areas. And we recently have discussed an opportunity for performing the reactions, or to obtain the once more, what's going on here? I should put some below, not to destroy my desk. That one is really reactive and not very good for drawing. Maybe I'll change that to the other one. Maybe that one will be better. Yes, that's the here. So we have quite a good one for A2 plus D. Sorry, A1 plus D2. But what if we would like to have A2 plus D1? And for that reason, we need an Umpolung concept. So, for example, we would like to change the reactivity first
of the Grignard reagent at the very beginning, and Grignard reagent will be, let's say, alkyl group, which is connected to the magnesium chlorine function, and a minus, a plus sign, of course partial charges here, but in accordance to the Synton's reactivity it will be something like that. Okay, that behaves very similar like that one. And then of course we will have here the alkyl, donor alkyl group, and to change that, to convert that into acceptor alkyl, we need a different reagent. It means the Rx, when X means chlorine bromine. It will be the acceptor alkyl. Once more, acceptor alkyl, and the syntons would be R plus, R minus here. So basically what we obtain is the differentiation, the reversion of the polarity of this syntons from the donor to the acceptor type. What we usually did in the laboratory is just the opposite reaction, so changing from the alkyl halide into the magnesium halide lipid, so to such a Grignard reagent. However, basically we do not necessarily need to use the laboratory to perform this Umpolung. Let's write here Umpolung. But we can also perform that operation simply by buying completely different reagent. So how we can perform the same reactivity change for these reagent as noted here? Let's say that we would like to change the Umpolung, so to perform Umpolung here, let's try to write it here, Umpolung, and okay, that's not what I would like to write here. That synton to reagent, that's synton to reagent, because we already have that. So we have the Umpolung from that one to that one, so that's the Umpolung, and we would like to note here the reagent that would react in that way, and this simply let's say that what we are writing here is D1 now, so D1 and in the way the so-called Ditian chemistry, what we would have here is just a formation